Okay, so sorry there was a small delay in the starting off. Okay, so we are going to start off with today's live session on projectile motion. So I'm going to introduce the basic concepts of projectile motion. So very simple idea. Everything that you throw and you let go on the surface of the earth is a projectile. That is, there is no powered flight. If I drop, that's a projectile. If I throw it like this, it goes up and comes down. That's a projectile. Most people think that projectile means you must have a parabolic path. Mostly that is correct. But if I drop it, that is a straight line path. That's also a projectile. If you throw it and it goes this way, that is also a projectile. Okay? But all parabolic paths are not projectiles. So for example, if you had a crow that went on a parabolic path, that won't be a projectile because the crow is going with powered flight. Here we are talking about all sorts of objects being thrown, but which are not powered. So you should not have powered flight. Let us start with some very basic ideas on how to calculate things in projectile motion. Before we get to projectile motion, I want us to first review straight line motion. So we'll quickly review straight line motion. You know a bunch of simple formulae, so we'll just start with some of those. You know these, right? For uniform accelerated motion, straight line uniform acceleration is constant. You would have learned this in the 9th standard. V equals u plus at. S is ut plus half at square. And v square minus u square is 2as. And my favorite formula is that average velocity is initial velocity plus final velocity, or final velocity plus initial velocity by 2. Okay, so now we will use all of these. I just want to quickly get some key ideas. When an object is dropped, acceleration due to gravity is supposed to be 9.8. We will assume that to be approximately 10 meters per second square. It's always a positive quantity and this is pointing downwards. The acceleration can be negative. G is always a positive number, just a number. So first question, if I drop this ball, what is its velocity? Drop basically means zero velocity, right? What is its velocity after 3 seconds? So if I drop this ball, its velocity is 0 meters per second. 3 seconds later, what will be its velocity? Every second it is increasing by 10, right? Initial velocity is 0, 3 seconds later its velocity becomes 0 plus 10 into 3 or 30 meters per second. Now we should be able to do this mentally, and I will show you the reason why, tell you the reason why in a few minutes when we get to projectile motion. Okay, where we are throwing an object like this or we are throwing an object like that, you want to be able to calculate it quickly, right? So let us look at this basic idea here. So if I look at 0 to 30, if I drop this object and I tell you that it has reached a velocity of 50 meters per second, how much time would it have taken? We can ask the question in reverse. Suppose now I told you this was 0, and if I ask you what happens or how much time elapses by the time it reaches 50 meters per second, how much would this time be? Well, every second it would have gone up by 10. That is the meaning of 10 meters per second square. So in 5 seconds it should have reached 50. So this must be 5 seconds. These are things you already know. I'm just rushing through it because you know it already, right? So I'm just doing a quick revision. So if I know the velocity, I know the time, and if I know the time, I know the velocity. So that is very simple and straightforward, and we should be able to do it mentally. Suppose I tell you I've dropped this ball, 2 seconds later what is the velocity? You should be able to say 10 plus 10, 20. Suppose I told you I threw this ball with 20 meters per second, and I asked you 3 seconds later, so I threw it with 20 meters per second, and 3 seconds later, what would be its velocity? Then you know that 20 plus 10 plus 10 plus 10, that is 20 plus 30, so this is 50. Okay? Now we could use average velocity here to say 0, 50, so average velocity must be 25. Or in general, if I say that this was 0 and the object travels for t seconds, the velocity here is gt. Because it started with 0, so the velocity is gt. Basically v equals u plus at, u is 0, so just gt. Now the average velocity for this case, 0 plus 50 by 2 is 25. The average velocity for this case is gt by 2. If I take g to be 10, it will be 5t. Okay? So 5 times 5, 25 is the average velocity here. Average velocity here is 0 plus 30, which is 30 divided by 2, 15. Now 15 is 5 times 3. So 15 meters per second is the average velocity. In general, gt by 2 will be the average velocity. Average velocity into time will give me the displacement. So this displacement is gt by 2 into t, gt square by 2. Okay, so the height that it is falling by is gt square by 2. Take g to be 10, 5t square. So for example, if I take this fellow here, the height it has fallen, this is 25 meters per second is the average velocity. Into time will give me displacement. So 25 into 5, 125. So the height it is falling by is 125 meters. I hope that is clear. In this case, 0, 30, average velocity is 15, 15 into 3, 45. Why are we doing all this? Because I want you to do this in reverse. So if I drop this ball and t seconds later it has fallen some distance, what would be that distance? Well, that distance will be 5t square. You can look at this formula if you want and say u is 0, half a t square, a is 10, so 5t square. Or you can say 0, 50, average velocity 25 into 5. 0, gt, average velocity gt by 2 into t, gt square by 2. Anyway, the important part is that it has fallen a distance of 5t square if it was dropped. That word dropped is important. Okay, what is this useful for? So suppose I drop this ball and it basically hits the table. Okay, so if I drop it and it hits the table, how much time does it take to hit the table? So let us say that from here till there, this distance was 20 meters. This is dropped 0 meters per second. This must be 5t square. So 20 must be 5t square, t square must be equal to 4, t must be equal to 2 seconds. So it's going to take 2 seconds to hit that table or 2 seconds to hit the ground. Of course, this is not 20 meters, so it won't take 2 seconds to hit the ground, right? Now, let us say that I'm dropping it from a height which is 80 meters. So suppose I say that it's basically 80 meters. You know that since it's dropped, 5t square must be equal to 80. So t square must be equal to 16, t must be equal to 4. So this is going to take 4 seconds. So if I give you the height from which you are dropping, you should be able to calculate time. That's possible? Everybody is clear about that? Can you quickly check, Madhu, if people have understood this? I drop it from a height of 125 meters. Total height is 125 meters. Tell me the time. Okay, I drop it, it is falling 125 meters. How much time will it take? Can you quickly enter the answer in that box? You have done that?
Yes. Is it 5?
Yeah, it's 5 seconds, right? So if it is going to fall a height of 125 meters, this must be 5t square. So therefore time must be equal to root of 25, which is 5 seconds. Quickly let us check whether it makes sense. Starts with 0. 5 seconds later, it hits the ground with 50 meters per second. Average velocity 25 meters per second. And therefore into 5, that is 25 into 5, 125. Suppose I told you I have a building and I am dropping from the top of the building a ball, so that means its velocity is 0 meters per second. The height of the building is 45 meters. How long will it take for it to hit the ground? So if you look at this question, 45 must be equal to 5t square. So t square must be equal to 45 by 5, which is 9. So t must be 3 seconds. So it will take 3 seconds to hit the ground. So I hope that is clear to everybody. Now this is something I'm going to use when we solve the next set of questions. So we were looking at a review of straight line motion. Now let us actually study projectile motion. Okay, so I'm going to erase this review of straight line motion. Let us get started off with some very simple projectile motion. So there are several parts of projectile motion that we need to study. I am going to first focus on horizontal throw. Let us start with a very basic idea that Galileo had introduced first. I have two objects. If I drop these two objects, they both hit the ground at the same time. So that is not something that is very surprising. Right? So if I drop it like this, they hit the ground at the same time. What Galileo also discovered was, if you had a small object and you had a big object and you drop them from the same height. Well, these two are going to drop from the same height, it's not a big deal. But if I had a basketball and I had a small tennis ball and I drop both of these, they should also hit the ground at the same time. Okay? Now this is a huge object, so it makes a lot of noise, but the point is they both come and hit the ground at the same time. They're making one single sound. So the time this guy takes to hit the ground, t, is the same as the time this guy takes to hit the ground. Okay, both take the exact same time. If this took 2 seconds, that will take 2 seconds. But what Galileo did was something even more interesting. He asked the question, if I had a third object, I know these two fellows are going to take the same time, but if I had a third object and I gave it a horizontal velocity. So this third object, we are not giving it a, we are not dropping it, we are not giving it an upward velocity, we are not giving a velocity like that. We are going to give it a horizontal velocity. So this is a horizontal velocity. How much? Doesn't matter. Let us say 3 meters per second. Well, it is going to travel like this and it's going to hit the ground somewhere here. It won't hit it at the same place. Will this take more time or will that take more time? So this time, let me call this T1. I have three options. I would like you to quickly tell me, is T1 greater than T? Because you see there is a distance which is longer. But then it already has a velocity, whereas this starts with 0, right? So this is 0. So possibility is T1 is greater than T, T1 is less than T, T1 is equal to T. Which of these three options do you think is going to happen? So can you quickly... So the correct option, of course, is, a lot of you have written this, it is the time for this fellow to hit the ground and the time for this fellow to hit the ground is the same. Let us see that with this experiment. So if I have a tennis ball and I have this basketball, I am going to push them. You will see that I can't make one of them drop, but what I can do is I can push such that one of them has a larger velocity than the other. Okay, so let us try that. Let us make these fellows have a larger velocity and hopefully they'll hit the table there. See that they're going to hit the table at the same time. Ready, steady, 1. So you saw that both of them take the same time to hit the ground, and this experiment was an extremely important experiment because this demonstrated that horizontal velocity does not affect the vertical motion. I'll explain why. Okay, just give me a second. So first point is that this time is equal to this time. But where is the ground? The ground could be the ground which is the table, right? So if I had set the ground here, then this time is equal to this time. That means when this ball was here, this ball would have been here. And this is valid for all heights. So at every height, when this ball is at this height, this ball is also at the same height, assuming they are both basically starting off at the same time. This guy has 0 velocity, this guy has a horizontal velocity. So what does that tell you? It tells you that the horizontal velocity does not affect the vertical time. But if it does not affect the vertical time, then from here to there, the time must be equal to the time from here to here. And if you made this time interval really small, that means the displacements are always, vertical displacements are always the same. So that means the vertical velocities must be the same, right? So the velocity of this object here and the velocity of this object there, vertical velocity must be the same. In addition, this fellow also has a horizontal velocity, but the horizontal velocity does nothing to the vertical velocity. That was a very, very important step. if the horizontal velocity doesn't affect the vertical motion, and then the question was, does the vertical motion affect the horizontal motion? Again, it does not. Vertically, you have an acceleration g, horizontally you have a velocity v, and this g is going to basically give it a vertical velocity. So let me call that v1. But this v1 and this v, they have no connection between each other. So these two fellows do not affect each other. That turns out to be a very useful step in solving problems. Let us see how. What I am therefore going to do now is convert this into a question that we can solve. For example, you have a building, and suppose I tell you from the top of the building, I take two objects A and B. So like this. Okay, so in fact let me have A here and let's say have B here. So this is A and that is B. Okay. Now I throw A with a velocity of 7 meters per second. I drop B, so it starts off with a velocity of 0 meters per second. B is going to fall here. A is going to fall there. Correct? Because it also has a horizontal velocity. If I tell you that B takes 3 seconds to fall, how much time will A take to fall? Same time. So what is the answer? 3 seconds. It is going to take 3 seconds to hit the ground. Correct? Because these two will both take the same time as long as that 7 meters per second was horizontal. But now the second part of the question is, how far away from the base does A hit the ground? How far away will it take to hit the ground? Now the vertical motion, the fact that A is moving vertically, should not affect its horizontal motion. Well, if it should not affect its horizontal motion, it was moving with 7 meters per second. It has an acceleration of 10 meters per second square because it has a mass m, it has an mg downwards, and that's the only force. So therefore this force will produce an acceleration of 10 meters per second square downwards, g. What is the horizontal acceleration? 0. But if horizontal acceleration is 0, it's moving with constant velocity. So if it's moving with constant velocity, then in 3 seconds, it should have traveled 7 meters per second into 3 seconds, which is how much? 21 meters. But then, during this time, it has also come down because of the vertical motion. So it has done this and it has done that. So therefore, how far from the base does it hit the ground? 21 meters. Notice that this motion is a combination of horizontal motion and vertical motion. The vertical motion of this ball is exactly the same as the vertical motion of the dropped ball. Okay? Let us think a little more about this idea. I am going to now look at this question. I am going to ask this question in a slightly different way. The same question. Okay, it's like numbers changed. This height is 80 meters. The height of this building is 80 meters. And we'll ignore air resistance, we'll ignore air. Okay, so this is an idealistic situation. From the top of this building, you take this ball and give it a velocity of 5 meters per second. How far away from the base, will this fellow hit the ground? Some of these questions are there in the worksheet that has been attached. You can download the worksheet from the website there. Okay. Now, I'm not going to look at that. I'll give you the question so you can start by doing these. 5 meters per second. This is 80 meters. How far away? This distance is usually called the range. How far away does it hit the ground horizontally? Basically, from the base here, what is the distance of the point where it hits? Come on, 2 minutes. So, shall we go? Now, let us see this. The time this ball takes to hit the ground is the same as the time another ball, if I had just dropped this ball, how much time would that have taken? Exact same time this fellow will take, right? So if this, let's call this ball A, that ball is B. There is no ball B, there is only a ball A. But you know that the time for ball A, which is thrown, and the time for ball B, which is dropped, both of them take the same time, right? If I throw this ball and I drop this ball, they both take the same time. So therefore, I can start with this ball B. But if ball B is dropped, you can use the formula 5t square, because that's only valid for straight line motion, right? 5t square is 80. That's why we learned this in the beginning. So t is equal to 80 by 5, 16. Root of 16 is 4 seconds. So who takes 4 seconds? Ball B takes 4 seconds. But ball B takes 4 seconds. Ball A takes the same time as ball B. So ball A takes 4 seconds. But during this time, ball A's horizontal velocity remains constant. Therefore, the distance travelled by ball A is 5 meters per second into 4 seconds. So that is 20 meters. So is that clear? Okay. So ball A is going to take 4 seconds and is going to hit the ground 20 meters away from the base. Now suppose I had asked you, what is the displacement of the ball? That would be the displacement of the ball. It's an arrow. And you know, we have already done a little bit of vectors earlier. Displacement, you know that you must use this direction as I cap and that direction as j cap. Right, I had done this earlier in some of the classes. So I cap is 20 meters, j cap is downwards 80, right? So therefore displacement S will be 20 I cap minus 80 j cap. Why minus? Because it's pointing downwards, meters. But range, we are only talking about the horizontal displacement. We are talking from the base, how far away did it hit. So I hope this idea is clear to everybody. So let us go on to the next kind of question. Okay, so let us think about this question. Think about it carefully and answer. It's an easy question, not very difficult. So you have here a building. Imagine that this thickness is very small. Like think of Eiffel Tower. Okay, it's a tower, it's a tall tower. And from the top of this building, you throw these two balls horizontally. One of them you throw in this direction, one you throw in the opposite direction. You're throwing like that. This fellow you throw at 5 meters per second, and this ball you throw at, let us say, 7 meters per second. Okay, so this ball goes and hits there. This ball goes and hits here. And the distance between these 2 points, let me call that point A and let's call this point B. AB distance, okay, AB distance is, let us say, 240 meters. My question is, what is the height of this tower? So find height of this tower. 2 minutes, come on, quick, 2 minutes. Okay, so shall we start off? Now, if you look at this question, you know that this distance is 240. But if this guy takes t seconds, this will also take t seconds. In t seconds, this would have travelled a distance of 5 into t meters. And this guy would have travelled in the same time 7 into t meters. So what is the total distance? 7t plus 5t, 12t. So 12t must be equal to 240. But if 12t is equal to 240, t must be equal to 20 seconds. But we don't want t, we want the height. Well, if I dropped the ball here, that ball would have travelled and hit the ground straight away like that, right? And how much would it have travelled? It would have travelled a displacement of half gt square or 5t square. So the height must be equal to 5t square, 5 into 20 into 20. So that is 400 into 5, 2000 meters. That's a really tall building, 2 kilometers high. Burj Khalifa is probably 1 kilometer high. There is no, therefore, tower which is actually of this kind of height, right? It's really, really tall. And also, of course, I've assumed here that there is no air resistance. If you had a height of this kind, definitely there will be air resistance, right? For smaller heights, we can use this. This is just after all a question. Shall we go to the next question now? Okay, so here is another question. Remember that all of these cases, the only thing that I am doing is throwing the ball horizontally. Okay, so let us complicate the matter a little bit more. You have a building, principle wise is the same. If you travel from the same height and you are throwing it horizontally, the horizontal velocity does not matter. So everybody moves down vertically by the same amount. Okay, so here is my building. Okay, and there is another building here. There is another building here at some distance. Now, from the top of this building, I am going to throw a ball. From the top of this building, I am going to throw a ball. And this ball, let us say, I am throwing, let me give you some numbers. So let us say that this height is 45 meters. This height is 45 meters. And this guy has been given a velocity of, let us say, 4 meters per second. Okay? So first question. If I tell you that this distance between these two buildings is 10 meters, where does this ball hit anything the first time? Where do you think it's going to hit? Is it going to hit the ground? Okay, actually it won't hit the ground. Okay, it's going to hit this building. I'm telling you that up front. So this fellow is going to go and hit this building somewhere. Question is, at what height from the ground does it hit the building? Find H, the point at which it hits the building, height from the ground. Come on, quick. Keep the other speaker. Okay, I see that in the chat box, quite a few people are doing it very well. Okay, so Sri Vidya has got it right. Kailash Gopal has got the previous one right. Shubhanand has got it right. Very good. And let us go to this. Adarsh, Pavan, Sheshwant. Okay, very nice. Arvind Sivaram, very good again. Muthuramalingam Ganesan has also got it. Rajesh Iyengar, Prajit has got it. Murli Mishra, very good. So I think quite a few people have got the previous question right. Let us look at this current question. How many people have got this current question right? Nobody has entered the answer. Come on, guys. Nobody's got it yet. Find the height above the ground. Shall we do this? So if you look at this question, let us assume that it actually hits the ground. If it hits the ground, how much time will it take to hit the ground? Well, if you drop a ball, how much time will it take to hit the ground? 45 must be 5t square. If I drop the ball, right? In that case, t must be equal to 3 seconds. But in 3 seconds, this guy will go 3 times 4 meters per second into 3, 12. So it would have gone 12, but this is only 10, right? So it cannot, well, if it has to go to 12, it has to hit it here. That means it has to go through the building, which means it would have hit the building at a height, right? It wouldn't have hit the ground, it would have hit the building first. Okay. So if it is going to hit the building, please keep in mind that how much time will it take to come to this building? If it takes t seconds, so suppose this took t seconds, that means in t seconds, not this t. This is the actual t, right? So in t seconds, it would have come this far. 4 into t must be equal to 10. So 10 must be equal to 4t. T must be equal to 10 by 4, 2.5 seconds. Correct? It is going to take 2.5 seconds to hit the building. Think about it. Okay, not many people got this right this time. 2.5 seconds to hit that building. Why? Because it's moving horizontally and the horizontal motion decides the time. So 2.5 seconds. Well, if it takes 2.5 seconds, in 2.5 seconds, how far will a ball drop? Because that is the height this guy also would have come down. So how much is that? This height, let me call this capital H, not small h, capital H. That is going to be 5 into 2.5 square. Okay? 2.5 square is how much? 6.25. 6.25 into 5 is 31.25 meters. Okay, so that is 31.25 meters from the top. But the building height is 45 meters. So therefore, this height must be equal to 45 meters minus 31.25. Okay, 45 meters minus 31.25. How much is this? So if I subtract, well, this is going to give me 14, so 13.75 meters. Okay, so I didn't see any answers with 13.75. I'll take a look at it soon. Many have answered that. Very good. Okay, so that's good. So if you've got it, extremely good. Okay, so shall we go to the next question? I hope you understood this question. Any doubts on this question?
No, sir.
No doubts? Everybody understood this?
There is one question.
Yeah.
Why 14.75 is wrong? Why Captain mistake?
14.75. Why is that wrong? Well, if you got 14.75, you basically did some subtraction mistake, right? Because it's 45 minus 31.25, that is just 13.75. So on the other hand, if you had done some other calculation, let's say you did 2.5 and wrote 31.25, this height you are calculating as 5t square, which is not true. Do you understand why we got 45 minus 31.25? Because this height is 45. The height it fell down in 2.5 seconds is 31.25. So that means the balance height must be 45 minus 31.25. Question is, why did it take 2.5 seconds to hit? Because it hits the building here first, before it hits the ground. If I had made a hole here and it could have passed through, it would have gone and hit the ground in 3 seconds. But even before that, it has already hit the building. So that means how much time does it take to hit the building is decided by the horizontal velocity. Why? Because 4 meters per second, 4 meters per second, 4 meters per second, like that. In 3 seconds, it would have gone 12 meters. But the building is there before 12 meters. So it has to hit the building before it hits the ground. Therefore, horizontal displacement is known, it is 10 meters. 10 meters must be 4 into t, so therefore time must be 2.5 seconds. Let us do one more question, so that should then clarify this idea. Okay, very similar question. I'm going to give you this question and let us see how many of you get this question right. So here is one building. Here is one building. And here is the second building. It's a nice, huge building. The second building is a large one. I don't know this distance. It's quite large. Okay. First building, the height is 45 meters. Second building height is 25 meters. You are going to throw 3 balls, A, B, C, okay? So, A, B, C, all from the same place. I can't show you here, so I'm showing it like this. It doesn't mean C is a little ahead, okay? It just means that A, B, C are all like this and you're throwing all of them like that. Everybody is given a horizontal velocity. A is given some velocity, C is given this velocity, B is given some velocity. So let us say that this distance between these two fellows, these two buildings, how much shall we keep it? Let us say that this fellow was 10 meters like before. Okay, so this is 10 meters. Now C is given a velocity of, let us say 5, no not 5, let's make this a little bigger, 8 meters per second. C is given a velocity of 8 meters per second. Let me also give you some x and y coordinates so that we can go ahead and discuss this. So I'm going to call this origin 0, 0, that's the x-axis and this is the y-axis. So you can then tell me x, y for where these fellows will hit the ground, okay? So A, x, y, B, x, y, C, x, y. That's what I want you to calculate. Wherever it hits, whatever first time it hits, that's the coordinate I want. So C has a velocity of 8 meters per second. B has a velocity of, let us say, let's see, give me a second. So I would like, hold on. So that basically means I want this fellow to be moving at 4 meters per second. So B must be moving at 4 meters per second. And I want A, this is just the axis, okay? This is not a velocity. So everybody has a horizontal velocity. A's velocity is 2 meters per second. So you've got A, B and C all thrown from at the same time from the rooftop of this building, right? So what was their initial coordinate? Their initial coordinate will be, everybody has 0, 45. Everything is in meters, 0, 45. I want you to tell me A's coordinate, B's coordinate, C's coordinate whenever they hit the first thing. It could be the wall, it could be the roof, it could be the ground. I don't care what it hits. When it hits something, tell me the time. Okay, come on, not the time, tell me the coordinates. Ready, steady, go. Start. Shashwant has got C correct. Okay, and Suraj has, no, that's not right. Okay, let's see. Yeah, Jayaseelan has got it right. I don't know who this poke bladder is, pokey bladder. Okay, but he's also got it right. And yeah, quite a few people have got C part right. Okay, Badri Narayan has also got C right. Some people have got C wrong. Okay, and some of you have got B. You've got B. Well, that's not correct for B. Okay, so 1225 I don't think is correct for B. Okay, so let us see. Okay, Suraj has said 1625 for C. Okay, that's correct. Suraj's answer is correct. And for B, somebody has written 10, 13.75. I think that is the correct one. Pokey bladder has got that right. And Priya Narayanan, for B, I don't think that is correct. 25, 31.25 is not correct. Okay. Okay, so shall we 1625? Chara Drimur has got 16,25 for C. That is correct. Okay, so let us start off. So let us first do this question. Now, first point, all of them are starting from here. I mean, this is just a distance I have shown, right? What are the possibilities? You can have this object come and hit the ground somewhere here. You can have an object go and hit the wall here, or you can have the object go and hit the roof there. You have three possibilities, and I told you the roof was quite far. I mean, this building was quite long this way, wide that way, so it won't go and hit the other side. Okay, because I told you it is quite large. Let us think. For you to go there, how much time will it take? Well, if you look at an object that is going this way, the only possibility is the fastest object could do that. Right? 8 meters per second is the one that can probably go there. If it was slower, it's going to do this. Even slower, it's going to do this. So, if anything, A must be here, B must be there, C must be there. Or you can have A here, B here, C there. All could hit the ground. Or you can have A here, B here and C there. That's all possible. Let us think about it. If you are going to go from here to there, that means C would have taken how much time to travel this distance? Well, this is 45, that is 25, so what is this? 20. So this distance is 20 meters. How much time do you take to travel 20 meters? Vertically, 5t square is 20, 5t1 square is 20. So t1 must be 2 seconds. That is, if I drop the ball, it will take 2 seconds to reach this height. But if I throw a ball horizontally, it will also take 2 seconds to reach the height. In 2 seconds, A is going to be here, B is going to be there, C is going to be there. I didn't know this before, no, I just told you. But we will see that that's what is going to happen. Okay, so in 2 seconds, how far away does C travel? 8 meters per second into 2 seconds is how much? 16 meters. Now this is only 10 meters. So this fellow has travelled 16 meters. So that is 16 meters. Correct? If it has travelled 16 meters and it has hit the top of this building, what is the x coordinate? X coordinate is 16. What is the y coordinate? 25. So C hits something, which basically hits the roof of that building at this point, and this point's coordinate is 16x and 25y. So 16, 25 in meters. So C's coordinate wherever it hits is 16, 25. So it hits it this place. Now let us go with A, because A is again very simple. A is going to hit the ground. How do I know? We will try it and see. Now to hit the ground, how much time do I need? Well, you are going to travel how much distance? In 2 seconds A is going to be here. My question is, when does it reach the ground? Well, it is going to travel 45. So 45 must be 5t3 square. Okay, I'm going to call the t1, t2, t3. So what is 5t3 square 45? What does that mean? T3 must be equal to 9, root of 9, so 3 seconds. In 3 seconds, A is here. So this takes 3 seconds. But in 3 seconds, A would have moved 2 times 3. When I gave you the question, I had to do this calculation. That's why it took me some time. Okay? Because I had to make sure A is going to hit the ground. So if it's going to take me 3 seconds to hit that place, 2 meters per second into 3 seconds, 6 meters. When A is here, where is B? Well, B should have been here, but by the time it's already hit the building. C should have been there, by the time it's already hit the roof. In 2 seconds, C is hit. B is still not hit. A is still not hit. In 3 seconds, A has hit. Between 2 and 3, B would have hit. Okay, let us see. So this is 3 seconds. This is 6 meters. What is its coordinate? Y coordinate. Y coordinate is 0 because the height is 0. X coordinate 6. So A has gone 6 meters, but Y coordinate is 0. So this is 6 comma 0. So I hope that is clear. Let us look at B. Now there is a possibility B hits the roof. In 2 seconds, if it hits the roof, it must have traveled at least 10 meters. But what is its speed? 4. 4 into 2, 8. So in 2 seconds, it has only come this far, which is only 8 meters. 8 meters, it has not yet reached the building, so it wouldn't have hit the building in 2 seconds. Maybe B hits the ground. So if B was to hit the ground, it would have taken how much time to come down to the ground? 3 seconds. So in 3 seconds, B would have traveled 4 into 3, 12. So it would have traveled 12 meters. But if it has traveled 12 meters, this is only 10 meters. So it would have hit the building before that. So you know for sure that B does hit the building. So let me repeat this part. If B hits something on the ground, if it hits a point on the ground, it would have taken 3 seconds. But if it hits a point on the ground in 3 seconds, 3 times 4, 4 meters per second into 3, means it has traveled horizontally 12. So from here, if you travel 12, you would have crossed the building, which means it would have hit the building before it hits the ground. Now suppose you said, no, it doesn't hit the building here, it hits the building roof. That means maybe it hits it here. Because you see, 3 seconds it is 12. But the problem is, if it has to hit that point, it is not 3 seconds, it's 2 seconds. Because it has only come down by 20 meters. So in 2 seconds, it has to hit some point here. But if it has to hit in 2 seconds some point here, in 2 seconds it only goes 8 meters. But the building length is 10 meters. So clearly it is neither there nor here. It has to hit some point here. Okay, so we know that it is hitting some point on the building. But what height on the building? How much has it fallen? I don't know. So you can't use height to calculate the time because you don't know how much it has fallen. See, if it falls on this, you know how much it has fallen vertically because this is the displacement. Whether you fall here, 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 the displacement will be vertically the same. If you fall on the ground, you know the vertical displacement. But if you hit the wall of this building, you don't know the vertical displacement because you could have hit here, 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 anywhere. What you do know is the horizontal displacement. You know that this is 10 meters. So wherever it hits, horizontal displacement is 10. So horizontal 10 must be equal to 4 into T2. Notice, for T1 and T3, I used 5T square. But for T2, I am using horizontal displacement is velocity into time. So what is T2? There I have used acceleration into T square. Half acceleration into T square. Here I am using velocity into time because here I know the horizontal displacement, I don't know the vertical, because vertical could be anywhere between 20 and 45. We don't know where. Okay, so but T2 must be between 2 and 3. We know that because it is 2 here, it is 3 here, and it is going to hit somewhere in between. So that means it's between 2 and 3. You can see it here, that is 2.5 seconds. We already calculated this if you remember the previous question. So in 2.5 seconds, this guy would have fallen down by 5 into 2.5 square. 5 into 2.5 square is 625 into 5, 31.25. Which means the height from the ground is 45 minus 31.25, which is 13.75 meters. And the x coordinate is 10. So B hits the wall 10, 13.75 0.75 meters. All these are in meters. So I hope this is right, clear? Everybody understood this? Now first let me answer one of the doubts that Hema Rajesh has asked. Can you explain why horizontal and vertical velocities are independent? Well, that is where we started the class, okay, but I'll just repeat it a little bit. Anyway, it's useful to learn once more. So basically there is an experimental evidence by Galileo. So Galileo's experimental evidence started out by showing that if you had a ball thrown horizontally and you drop this ball, then this ball and this ball, drop ball or any other velocity. So in fact, let me come up with 3 balls. One ball, second ball, third ball. So this fellow I am giving it 5 meters per second. This guy I am giving 7 meters per second. This is dropped. What Galileo showed experimentally is that this fellow goes like that, this fellow goes like this, and this ball drops down. You pick any time, it takes the same time to hit the ground, and you can set the ground at various levels. So if you ask 1.1 seconds later, this ball is here, this ball is exactly at the same height. If it was not and I had kept my ground there, it would not have hit at the same time. How does this ball know that I'm going to keep the ground there? It doesn't know, right? So that means it must be there anyway. So when this ball reaches that place, at that time this ball must reach here. These two must basically move such that at every time they are, at every instant, they are at the same level. At 1.1 seconds, this fellow is here, this fellow is there, this fellow is here. Everybody is at the same level. What does that tell us? That tells us that you don't need the 5 meters per second to calculate this guy's vertical motion. So if you take this motion, you split it up as horizontal motion and vertical motion. The vertical motion for this ball, A, B, C, vertical motion for A is the same as the vertical motion for B, is the same as the vertical motion for C. The horizontal velocity does not matter. In fact, this is all easy to say. What you should understand is if I took a gun, I had a bullet, and I dropped an apple, and I shot with a bullet, the bullet is going to take a long, like it's going to travel a long distance. So if I took a gun and I shot it from here, and let's say I drop it, by the time this apple comes and hits this place, this bullet would have traveled like that, right? It would have traveled such a long distance, but exactly at the same time this fellow comes down, this bullet is going to hit the ground. Exactly at the same time. Okay, now that's not such an obvious statement. It looks like this guy is traveling such a long distance. Correct, but the vertical motion is the same and is not affected by the horizontal motion. This guy may have a very large horizontal motion, 50 meters per second. But its vertical motion is exactly like the vertical motion of the apple. So if the apple was here, this bullet must be here, same height of fall. Okay, later we will see that you can extend this idea. If you took a bullet and you shot it like this, if this thing goes up and comes down like that, you should think of it this way. From this point, this is where it should have been, it would have come down by exactly the same distance that if a ball was dropped, this would come down, right? If this goes down by x, from where it should be, this will go down by x. So this bullet should have been here, but it comes down by x. How much is that x? Half gt square. This guy comes down from here because it should have been there and comes down from here. A should have been here and it comes down from there. C should have been here and it comes down from here. Everybody comes down by the same amount in the same time. Experimental evidence. Okay, this is not something you can just cook up and think of. Galileo did a lot of experiments on this. What this shows is that your horizontal velocity does nothing to your vertical motion. So if you didn't have horizontal velocity, how you will move vertically, exactly the same way is what you're going to do when you have a horizontal motion. If you have 5 meters per second, you will move the same way vertically. You have 7 meters per second in the opposite direction, you will move the same way vertically. You are dropped, you will move the same way vertically. So the 5, 7 dropped, etc. makes no difference to the vertical motion. Okay, there's one more requirement. I know horizontal doesn't affect vertical, but maybe vertical affects horizontal velocity. Maybe. Okay, Galileo also did experiments to show that. Okay, one of the experiments is a famous one. I didn't talk about that today, but I'll tell you. Okay, we can do one mental experiment, mind experiment. Einstein was very famous for coming up with hypothetical mental experiments. He called these, I think, Gidekinnan experiments. You imagine motion in your head. Okay, but anyway, so Galileo also did some of these experiments. I'm now just going to tell you one experiment that Galileo didn't do, but I'm just cooking this up. Okay, but you will get the idea because this is easy to see. Imagine this experiment. I can't do it and show it, unfortunately, but imagine this experiment. If I had a table, smooth tabletop, and I have a ball at the top and I have a ball at the bottom. I give both these fellows the same velocity, let's say 3 meters per second. Imagine this was a very long table. What will happen? A and B, A is right above B. If A moves from here to there, where will B be? Right below. If A moves there, B is again right below. A comes to the edge, where is B? Right below. So far okay. But now what is going to start happening is the table has ended. So after this, A is not going to only move like this, A is going to move like this. And this is the experiment. Okay, I am not showing it, but if you do it very carefully, you can. By making these fellows move, what is interesting is, every second B is moving how much? 3 meters per second. So the next 1 second B moves 3 meters per second. A is still right on top. A has moved horizontally 3 meters per second, but it has come down. It has moved the same amount, but in addition it has come down. But the fact it is coming down has not changed how much it moves horizontally. What does that tell you? The vertical motion is not affecting the horizontal motion. 1 more second later, B is here and A is there. Right above again. So B moved 3 meters, A moved horizontally 3 more meters, but vertically now it has even moved more, because in first second it will move 5. 5t square means 5. Second it has to move 20 minus 5, because 2 seconds it will move 20. 5 into 2 square, 20 minus initial 5. So this is 15. It has to move much more. Okay. Next 0.1 seconds B is here. A is going to hit B. So the experiment is, you get these two fellows started with the same velocity. Do they collide or not? If they do, you know that A was moving horizontally exactly the same way that B was moving. It doesn't matter what the mass of that fellow is. It doesn't matter what the mass of this fellow is. Okay. It doesn't matter what the shape of that fellow is. What matters is they both have the same horizontal velocity. Which means this guy's horizontal velocity is not affected. You know, obviously this is not even falling. So this is moving with some horizontal velocity. That fellow's horizontal velocity is not affected by the fact that it is also falling. Do you understand that for this part, there is nothing? Of course, B was moving 3 meters, 3 meters, 3 meters every second. A was moving 3 meters, 3 meters, 3 meters. A was also not falling, B was also not falling. This is easy. After this, A moves 3 meters, B moves 3 meters, A falls. But A did not make that 3 meters into 2.7 meters. A did not become more distance or less distance. A moves the same horizontal distance. Next second, B moves 3, A moves 3. A could have moved 4, 5, no, because it's moving down. In addition to moving horizontally 3, A is also moving down vertically. But the vertical does not affect the horizontal. Now Galileo did not do this experiment or explain this, but I think it would have been a nice experiment to do. Okay, I have done this a few times in class, but it's very tough to do it because you see, the problem with this is I have to make sure that that velocity and this velocity are given at the same time, same velocity. It's not easy to give. Horizontal velocity is easy to give, but making sure they are 3 meters per second, well, you need a gun, you need to make sure that you are pulling with a spring. It's a little bit more work. Okay, so I'm not doing that now, but I hope the idea is clear. I'll tell you what is the experiment that Galileo talked about. Okay, that's also good fun. So what Galileo did was to say, you have a boat, a ship. Ships usually have this mast. Some of you may have seen this, what is that movie called? Pirates of the Caribbean, right? So if you see in Pirates of the Caribbean, this fellow goes up and so on, right? So think of a mast like that. Now, from the top of the mast, Jack Sparrow is trying to drop an iron ball on top of somebody here. Okay, so he's asking this guy to look up and he says, okay, I'll drop, catch it. This is an iron ball, so obviously it's going to break his head. So if he drops it, it is going to hit the ground, hit the ship straight vertically on his head. Correct? This is if the ship was at rest. Okay. Now let us say the ship was moving. Suppose the ship was moving. There are three possibilities. If this guy carried the ball, iron ball, the ball moves with you. Correct? The ball moves with you. So if the ball moves with you, it also has a velocity. So when he is releasing it, the ball has a velocity. Now it's possible that the ship is actually moving forward, right? So after some time, the ship is here. But the ball was released here. The mast is here. And this man is standing here. Right? If it was stationary, if I drop it there, you expect that it will come and fall on your head. But if you are dropping it on a moving object, and so this ball, as it's coming down, is also going forward, it is possible that it could come and hit here. What is happening then? That means this ball would have moved here because Jack Sparrow would have moved till there. But the ball has moved less than Jack Sparrow. Then what will you conclude? When you drop it, the horizontal motion is less than when you don't drop it. It is possible that it comes and makes a hole here in the ship. It's also possible that when you drop it, it goes and makes a hole there. But suppose it came and fell on this guy's head. What does that tell you? It will tell you that if I did not drop the ball, which means it did not have a vertical motion, it has moved how much? X meters. If I drop the ball, it has again moved X meters. Which means the fact that I dropped the ball made no difference at all. Is that true? Yes and no. It is true if the ship was moving with, so this is true if the ship was moving with uniform velocity. But it's not true if the ship was accelerating. Ship was accelerating. Because let's say the ship was moving faster. It started with some velocity. So this guy has, let's say, 4 meters per second, which is the ship's velocity, 4 meters per second. As long as the ship kept going at 4 meters per second, this will come straight and hit his head. As far as the fellow on the ship is concerned, it will look like it is coming this way. Actually, it is not coming this way. It is coming this way. Okay, so it's moving like this. But this has 4 meters per second. The ball has 4 meters per second. And as it's moving, it keeps 4 meters per second, 4 meters per second, 4 meters per second, and it comes and hits the ground. Hits this guy's head. If it was accelerating horizontally, the ship was accelerating horizontally, let's say speeding up, starts with 4. Once you leave it, it will be 4. If it's accelerating, by the time it reaches here, let's say it becomes 6. But this ball has only 4. So the ball continues, it will have come and hit the ground or hit the ship here. It won't hit the ship there because the ship is moving more than that 4 meters per second. So I hope the idea is clear. You can see this. I can show you this quite easily. If I drop this ball, it is going to hit my head. Right? Now, if I am walking and I drop this ball, the question is there are two possibilities. Once I release the ball, so if I am walking with the ball comes with me. But if I am walking and I release the ball, one possibility is the ball falls behind me. One possibility is because I released it, the ball falls ahead of me. Another possibility is it comes straight down. But I am walking. So if it comes straight down, what happens is your brain assumes that you are me. And therefore you think it is falling like this. But that's not the case. I am like this. So the ball should have come down. But I am actually going to this place. The ball has the same velocity as me. And the ball hits my head there. If it hits my head is there, remember. I am not going to be here, I am going to be there. If it still hits my head, that means the ball is moving like that with the same velocity. So shall we see? Ready? First I'll drop it and see. Okay, so that's 1. 1, 2, 3. I must be walking with the same velocity. You saw that it came and hit my head, right? It's easier if I drop it and you catch it here, because that is slightly better. And I have a nice stomach, so that basically allows me to catch it. So let me drop it. Okay, ready? I'm not seeing it. I can't see it. If I drop and I start walking after I drop, then that's what will happen. Okay, that's not what I want. I'm going to drop as I'm walking. So first I start walking, then I drop. Okay, so let me show it again. I'm walking and then I drop. So it comes back to my hand. So if it's a longer stretch, then I can do that a little better, but the basic idea I hope is clear. If I drop it from here, it comes to my hand. As I'm walking, assuming that I'm traveling with same velocity, it still comes to my hand. So the horizontal motion is not affected by the fact the ball is moving vertically in addition, right? So the additional motion, vertical motion, makes no difference to the horizontal motion. Now these are the things that after Galileo, people started summarizing. We call all of what you have learnt, we say in one word, using the word vector. Velocity and acceleration are vectors. Okay, that statement says it all. Let me explain carefully again. Displacement, velocity, acceleration are all vectors. Why is that important? Because when you take a vector, one of the first things that we have learnt in vectors is that the x component, I cap, does not affect the j cap. These two are independent. But isn't that what we are now saying? Horizontal velocity does not affect vertical. Vertical does not affect horizontal. Vertical acceleration affects vertical velocity, does not affect horizontal. Right? So, if you had 10 j cap minus 10 j cap, whatever you do here, you will get j cap. Minus 10 j cap into 5 seconds will give you a velocity. This meters per second square, that is seconds, so you will get meters per second, minus 50 j cap. You don't get I cap, you only get j cap. So the j cap is not affected by I cap is not affected by j cap. So I hope the idea is clear. So basic idea, velocity is a vector. By the way, that requires experimental evidence, and that's what Galileo did. Once you say velocity is a vector, then you don't need anything. But that's mathematical, because when you say velocity is a vector, how do you know velocity is a vector? That you don't know. That you know only from experiment. What Galileo did was to say velocity behaves like a vector, because the I cap component and the j cap components do not affect each other. So I hope this is clear to everyone. Let us take one step further and ask, so far I was throwing everything horizontally, which is a good thing. We have many more nice questions to do with horizontal velocity. So shall we continue with horizontal velocity, or shall we try one without? Let's go a little further and go one step more. Let us start with a simple case. Okay. I'm going to take a ball and I'm going to throw it from here. I'm going to throw it like this. And let us say that I'm throwing it with a velocity in this direction and that direction. That's basically the meaning of saying the velocity is in this direction. Let us say the velocity was 4 I cap plus 6 j cap meters per second. What is the meaning of I cap? This, horizontal. What is the meaning of j cap? Vertical, upwards. Correct? So this ball is going to go like that, and it's going to hit the ground somewhere there. Now we also know that if you took a ball and you threw it up and it's coming back to your hand like this, if I threw it with 7 meters per second, when it comes back, it will come back with what speed? 7 meters per second. How do you know this? Well, here it has some kinetic energy, it has some potential energy. There also it has the same potential energy because it's back where it started, so it must have the same kinetic energy. That's one way. That is the same statement as saying v square minus u square is 2as. But I like a better way. Where is it? It's back where it started. What is its displacement? 0. What is displacement by the time? 0. What is displacement by time? Average velocity. So average velocity is 0, but it is uniformly accelerated. For uniform acceleration, v plus u by 2 is average velocity. This is 0. So what does it tell you about v and u? V plus u must be 0. V must be equal to minus u. It not only tells you it must be 7, it tells you it must be minus 7. If this was plus 7, it is minus 7. Clear? Right? Okay. Now if you know this is 7 and that is minus 7, and let us say that that was the positive direction, then how much is the time it takes to go from here to there? What is the time? We know that v minus u is at. Now all of this we have already done in straight line motion. Some of you may be a little bit shaky because you have not done it as revision for a while. So we will do that. We'll come back and do straight line motion in more depth. So when you do that, you will feel that this becomes easy. I'm just introducing this for projectile motion. So just follow me here. So if I'm taking that as the positive direction, what about this guy? Minus 7. What is u? Plus 7. But I have minus of plus 7. And what is the acceleration? 10 downwards, which is minus 10. So this is minus 10 into t. So if you notice, the change in velocity is minus 14, acceleration is minus 10, so time must be 1.4 seconds. Very simple. 7 becomes minus 7, time must be 14 by 10, 1.4 seconds. How much is the time from here to 0, to the top? Velocity there is 0. So from 7 to 0, how much time? Change in velocity? 7 divided by 10. Minus 7 by minus 10. So therefore it is 0.7. It takes 0.7 seconds to get there and 0.7 seconds to come down. So total time 1.4 seconds. Okay? So can you please remove that phone? Yeah. Now let us come to this. If I throw this with 5 meters per second, it comes back. Can you quickly tell me, like I would like these questions answered very quickly. 5 meters per second, it comes back. How much time? 5 meters per second upwards, it comes back to this point. How much time? Come on. Done? 5 meters comes back. 1 second. Because 5 meters per second, when it comes back, it will be 5 meters per second downwards. Correct? 5 meters per second up. 5 meters per second down. So the change in velocity is minus 5 minus of plus 5, which is minus 10 by minus 10. Change in velocity by acceleration. So time, very simple. Time is change in velocity by the acceleration. And in our case, the acceleration is minus 10. So change in velocity by minus 10. Here I am taking upwards as positive. Now this is a very useful technique, right? Very simple. So if you look at this guy, what are the things that we already know? We know that the vertical velocity is not affected by the horizontal velocity. So if there was another ball that was thrown up with the same vertical velocity, but what is this guy's vertical velocity? 6j, which basically means 6. So this was thrown up with 6 meters per second. If this guy reaches this point, this guy will reach that point. When this guy reaches the topmost, this guy will reach the topmost. When this guy is back here, this fellow is going to be back there. Is that clear? The vertical velocity is not affected by the 4 meters per second. So what is this guy doing vertically? Exactly what this guy is doing vertically. But you know what this guy is doing vertically. So when this guy goes and hits the ground, what is this fellow's vertical speed? Well, what is this guy's vertical speed? Well, if it was 6, what is that? 6 down. So this guy will have a vertical velocity of minus 6j cap. But in addition, it also has a horizontal of 4i cap. 4i cap. This guy does not have 4i cap, but that doesn't matter because the verticals will be the same. So if this is 4i cap, all the way till the end it has 4i cap. How much time will this fellow take to hit the ground? How much time will this fellow take to hit the ground? 6 becomes minus 6. How much time? Minus 6 minus plus 6, which is minus 12. Minus 12. So minus 6 minus of plus 6 minus 12 by acceleration minus 10. How much is that? 1.2 seconds. So this ball takes 1.2 seconds. How much time will this ball take to hit the ground? 1.2 seconds. What is this displacement? What is this range? 1.2 seconds into 4 meters per second. 4 meters per second into 1.2. How much is that? 4.8. So this ball is going to take 4.8 meters away. It's going to hit the ground and it's going to take 1.2 seconds to do this. Did everybody understand this? Can you please quickly put it in the comments? If you have understood, we can go ahead and start looking at problems. Can you quickly check?
Many got 4.8 as well.
Okay, so they've got it. And did everybody understand it? If you want me to explain, I'll explain this again. Anyway, we'll do the next question so you'll see that more clearly. Okay. Let us start with this question. I'm going to take a ball, I'm going to throw it like this with, let us say, 10 I cap plus 12 J cap meters per second. In all these questions, we are assuming G is 10 meters per second square. We've already done that. So this guy goes up till the top and it comes and hits the ground. I want the following things. Now I'm going to add a little bit more, okay? So I want the following things. Total time of motion. Total time of motion. So let's call this point A. Let's call that point B. So I want AB time. Time to go from A to B. Second, I want the range, which is basically the distance AB. Okay, but that's not enough. I also want the time to go from A to C. And I would like you to calculate what's the maximum height. 4 questions. 1, 2, 3, and this is 4. Can you quickly do this? There are 4 questions. I'll give you 1 minute. So 3 minutes or 4 minutes basically to quickly solve the problem. Hey, it's looking, a lot of you guys are fast track students, right? So you already know some of this. That's why you're answering so quickly. Okay, so, okay, good. But can the other people who are not attending the fast track batch, can you also please enter the answers? Some of you are doing that, I can see. But yeah, good, good. So Sudha has asked, what is I cap and J cap? Let me explain. Some of you have already done this, that's why I kind of assume that you know it. Okay, so I cap basically just means x direction, positive x direction. Unit size in that direction. To instead of saying you have 3 meters per second horizontal and 5 meters per second vertical, that's going to be very hard for us to write, right? So you say 3 in the x direction. So instead of saying x direction, we say 3 I cap. So 3 I cap just simply means in the x direction 3, in the y direction, let us say 5. I will write 3 in the x direction. So that's what I'm writing by writing I cap, plus 5 in the y direction. So that basically means 3 like this, 5 like this. So the actual velocity is pointing some weird angle, 3, 5. Okay, so that is basically the meaning of I and J. Pararth Mishra has asked a very interesting question, a very good one. Earth has a circular path. So if we try these experiments, then it shouldn't happen like what I have just explained. Absolutely correct. Absolutely correct. I am hoping you won't take the ball and throw it with something like 7,000 kilometers per second kind of speed. Hopefully not. So you're talking about 7 meters per second. Earth's curvature is like that. No, Earth is like a very, very large object. So for all reasonably small velocities, it will be like a straight line, so it will go and hit. But in reality, you are right. Earth is curved. So if you throw it from here very fast, then by the time it goes there, the flat thing is here. If you fall here versus falling there, there's a difference. In fact, that's why things go in a circle. Like for example, if you want to get this ball into satellite mode, you give it enough velocity, it is supposed to fall down, but the Earth is also curving. So it will just keep going, keep going, keep going and come back. So maybe that's something interesting for you to look at later. There is a very interesting site, I think it's called Newton's cannonball. Okay, it has an experiment where you can throw this ball at various speeds. So there is a huge mountain from which you throw a cannonball, and that shows you the Earth's curvature, so you can actually show what is going to happen to that ball. But you are right. If we throw it so fast that the curvature of the Earth matters, then what I said is not valid. Okay, so one of the assumptions for projectile motion is the speeds are small enough that we can ignore the Earth's curvature. We will also assume that there is no air. The speeds are small enough that you can ignore air. So there are quite a bit of assumptions, right? But those are important because that allows you to do the calculations much faster. It gives you an answer within those constraints. So projectile motion makes those assumptions. So, but that's a very, very good question, Pararth. Okay. Aravind Sivaram and Jayasilan have asked, how do we know the balls do not collide and their paths do not cross? I am assuming this question is about those 3 balls ABC. Okay. Well, all of them started here. Actually, I told you, but maybe not explained it so clearly. You are throwing them like this. So they are all moving in 3 parallel paths. I mean, the beginning they start with parallel velocities being parallel. So therefore, there is no way they are going to collide. They are not going to go this way. They are not crisscrossing. But even if they started like this, let's think about that. This guy is the fastest. Well, if you're starting that way, maybe it will crisscross to some extent. Obviously, it will hit it, right? But if it starts like this or starts from the same place, this guy is 8 meters per second. So this guy is going off that fast. Whereas this fellow is going like this and this fellow is going like that. At the beginning, they might have been at the same place, but after that, their paths will never cross. Okay? You can see that. So if I start from the same place, the fastest fellow is going to go like that. The next fellow is going to go like this. The next fellow is going to go like that. If they could have crisscrossed, they could have crisscrossed there. After that, there is no way these fellows are going to crisscross. So therefore, there is no crisscrossing of these balls in midair. Okay? Is it possible that 2 of these objects can crisscross? Of course they can. That is possible. In fact, we will do a problem next with that. But right now, let us not worry about it. So can we get to this question? How many people have answered this question?
Many have answered here.
People have answered?
Yes.
Okay. So let us start. I know I'm going a little bit faster today. Some of you may feel no, because some of you have already done part of this course. Okay. So, but I would like you to go through this whole set of things online. I'll put it up. This is basically a full book with lots of questions, and it's important that you do these questions step by step. I have given in the online course itself, there is a small exercise worksheet which has, I think, about some 40 questions or so. Very easy questions, not all of them, some of them are tricky. So try those questions out. Okay, so shall we start with this? First, whatever this fellow does, it is exactly the same as a ball that had the same vertical velocity as far as the vertical motion is concerned. So this guy has 12 meters per second, this guy has 12 meters per second, because the 10 meter per second horizontal does not affect the 12 meter per second vertical. But if it is going at 12, it will go up and it will come back down. When it comes back down, what will be its velocity? Minus 12. So here, the velocity of this fellow will have a minus 12 j cap. But it will also have a horizontal velocity of 10 I cap. At that point, again, it is going to have 10 I cap. Clear? How much time will it take for this fellow to go up and come down? Change in velocity, minus 12, minus of plus 12, so minus 24, minus 24 by minus 12, 10, right? Acceleration is minus 10. G is always 10, but acceleration is minus 10 in this case. I'm assuming up is positive. So whenever you use I and J, J is upwards positive. So that means you don't have to assume down as positive, you assume up as positive. Minus 12, minus 12, minus 24, minus 24 by minus 10, 2.4 seconds. So this time is 2.4 seconds. That is the time to go from A to B. So this time is 2.4 seconds. In that time, how much distance would it have traveled? Well, it was traveling at 10 meters per second horizontally. So 10 meters per second into this total time, which is 2.4. So therefore, the distance AB is 24 meters. 2.4 into 10, 24 meters. The time from A to C, just look at it. You know it must be half the time. This is cheating, no? But we'll do it and then I'll show you that it must be half the time. So time is 1.2 seconds. But this time, isn't it the same as this time? At the top, what is the velocity? 0. What is the change in velocity? 0, final velocity minus initial velocity 12. So change in velocity is minus 12, correct? V minus U by A. A is minus 10. So how much is this? 12 by 10, 1.2 seconds, which is what we got. It is exactly half time, right? So time from A to C is 1.2 seconds. In this time, how much would it have moved here? Well, it would have moved 10 times 1.2. So that would have been 12 meters. But that is not the question. It would have moved half distance. That is 24. It has moved 12. That's why projectile paths look symmetric. So if you see, it looks symmetric, right? Because whatever time it took to get there is the same time it takes to come down. Because whatever time it took to go up is the same time it takes to come down. These two are connected. Okay. But I'm not asking you this. I'm asking you for the maximum height. But this guy's maximum height, isn't it the same as this guy's maximum height? Vertical motion, right? But what is the final velocity there? 0. What is the initial velocity? 12. So from here to there, what is the average velocity? 6 meters per second. And how much is the time from here to there? 1.2 seconds. So therefore the height h must be 6 into 1.2. Average velocity into time. You can't do 12 into 1.2, but you can say average velocity into 1.2. So that is 7.2 meters. So the maximum height must be 7.2 meters. Can I do it another way? Yes. You can say v square minus u square is 2as. So let's do it that way. So if I use v square minus u square is 2as, then you can write s is v square 0 minus u square, which is 12 square 144 by 2 times a, which is minus 10. So you can see 144 by 2 is minus 72 because there's a minus sign. Minus minus cancels out. 72 by 10, 7.2 meters. I don't like to use this type of a formula. I like to say, okay, from here to there, this guy only has a horizontal velocity at that point, 10 meters per second. Its vertical velocity is 0. So vertical velocity was 12 meters per second. Vertical velocity is 0. So average vertical velocity 6 and time 1.2. So average vertical velocity into time, so that is 7.2 meters. So I hope you have understood this. Okay. Let us now take an idea. Did everybody understand this? Do you want a question of this kind? One more? Let's try a question. I'll cook up a question which probably involves small amount of trick. Not very much, very simple one. A small amount of trick. Did everybody understand this? Quickly check. People understood this? Okay, good. So let us go on. I'll come up with some question. Well, I'm erasing the board. Let's think. Okay. Somebody asked about these two balls colliding. So let's make these two balls collide. So I have here a building. And from this building, I'm throwing a ball straight. Let us say 6 meters per second. How tall should this building be? Let us make this 20 meters. Okay? And this ball comes like that. And from here, you throw a ball. And that ball travels like this, and both of these fellows collide in midair. Okay? How far away do you want this ball to be is the first question, right? So let us think about that. That's what, give me a second. I want this to be 16 meters. This looks taller, but I mean this looks longer, but assume that this is 16 meters, just for some numbers so that numbers become, no, not 16, sorry, 15 meters. So this is 15 meters, okay? And I don't know what angle I'm shooting this fellow at, so I don't know that. But I know that these guys are going to collide. I know that they are going to collide after how much time? Let us say that they are going to collide after 1 second. They collide in, or let us say that the collision time was 1. Shall we make it 1.5? Let us make it 1 second, simple. So collision time for collision is 1 second. You basically, time for colliding is 1 second. 6 meters per second. 1 second later they collide. That's what I don't know. So that's your job. Find this velocity vector. That means you must tell me how much I cap and how much j cap. So it will obviously have some negative I cap and some positive j cap. Try this out. In 1 second they collide. This is a little bit of a hard question. Let us see how many people get this right. Okay, so shall we look at the question? I saw that some of you have already done it. 1 second later, well, this guy is going to come down by some height, right? What height? So where is this position? You can find out the position quite easily. Because in 1 second, this guy would have fallen down by 1 second. 1 second's time is 5. Remember, it is 5t square. I've been using 5t square. You probably know the formula ut plus half at square. Because this comes up so often, I'm just using u0 because initial velocity, horizontal velocity, vertical velocity is 0. So u is 0. A is 10 because it's g. So 10 by 2 is 5. So s is 5t square. I use that all the time. So just for calculation so that it becomes very easy. Quickly 5t square. If they told you that g was 9.8, which is the correct number, then instead of 5 you will end up with 4.9t square. But we will use 5t square for calculation. So in 1 second, this is 5 into 1 square, which is 5 meters. So from here, it has travelled up by a distance of 15 meters. This guy has travelled up 15 meters. Correct? Okay. We have to think very hard about this. And how much has this guy moved this way? It has moved a distance of 6 meters. How? 6 meters per second for 1 second. 6 meters. So what is this distance? 9 meters. Some of you have written, therefore the velocity is minus 9 I cap plus 15 j cap meters per second. Now this unfortunately is not correct. This is correct for average velocity. Are you telling me that this ball is going to move like this? No, right? It will also go up and bend. So what is my initial velocity? Well, first thing, the horizontal velocity won't change. So the horizontal velocity, yes, you are right, it moves 9 meters in 1 second. So horizontal velocity is 9 meters per second in this direction. So minus 9 I cap, no problem. But vertical velocity? Now that's something we have to think about. Because in 1 second, this guy has travelled a distance of 15 meters. S is 15 meters. Okay, so if S is 15 meters, you can use the formula S is equal to what? Ut plus half at square. Ut plus half a t square. I'm going to call this initial velocity as u, upward. What is S? S is 15. Upwards is positive, so S is 15. U, I don't know what U is. I'm just going to call it U. What is T? Well, that is 1 second because it travelled for 1 second. So it is 1 plus half. Now what is A? Minus 10 because it's downwards. No, remember there is an A, minus 10. T square, which is 1 square. Okay, this is 15, this is minus 5. Bring it to this side, so you'll get 20. U is 20. Weird that U is 20. Is it weird or it's not so weird? Let us see. This is 20 meters per second. Let us think about this. In 1 second, 20 meters per second will become how much vertical velocity? 20 up, 1 second, acceleration 10 down. So 20 up, acceleration 10 down will make it final velocity of how much? V equals U plus AT, U plus minus 10 into 1. So at this point, this guy's vertical velocity, this fellow's vertical velocity will be 10 meters per second. 20 minus 10, 10 meters per second. Average velocity, 10 plus 20 by 2, 15 meters per second. Average velocity is 15 meters per second. Initial velocity is not 15 meters per second, it is 20 meters per second. So you need to do a little bit extra calculation, okay? Now I know this is my vertical velocity, this is my horizontal velocity. So my velocity vector is minus 9 I cap plus 20 j cap meters per second. So I hope that is clear. Many of you got it right. Now let me explain something very, very important, because with projectile motion that's very critical. I know many of you are super smart. Okay, and many of you are aspiring for IITs. If you are looking at IIT entrance, it's obviously a hard exam. There are some 15 lakh people who are preparing, 13-14 lakh people who write every year. Okay, and they select something like 10,000 students, right? 15,000 get some ranks, and then at the end 10,000 they select. Now if you look at this, there are multiple steps that you need to do. First, you must understand the concept. Very, very critical. Like for example, if I took these two balls, and you can remember formulae. Formulae is not the same as concept. If I take these two balls and throw 7 meters per second, 2 meters per second, they take the same time to hit the ground. That's concept. It's an idea, an experiment that should be in your head. Horizontal and vertical, independent concept. Okay. Formula for some of these, of course you might remember, but that's not really concept. Like projectile motion has a bunch of formulas. I have not even introduced the formula today. I'll come back to it at some point. My last question in projectile usually is formula introduction. Okay, because if you start with the formula, people just start focusing on the formula, which is not very useful. So concept understanding deeply, as deeply as you can, very critical. Now people assume that if you know the concept, you can directly get to applications. I'll call these IIT applications. That's not true. There are many steps in between. That's why I've written so many gaps. There is a very, very, very important step which I'll call skill building. You need to make sure not only that you have understood the concept, that you can actually calculate. This 5t square is skill building. Some of you know it, some of you don't know it, but if you spend enough time on it, do some 7 questions, 8 questions, you will find that you will be able to do it no problem. It is nothing big. You understood the concept. Skill building requires extra work, a little bit of work. By solving hard questions, skills do not get built. Please remember, to build your skill, you need easy questions that separates out that little particular skill. You focus on that, you work on that a little bit, your skill gets built. So skill building is extremely critical. Like many of the questions I have prepared are very easy, but if you get the point, you will be able to solve it. Okay, that part is very important because it's a one-step thing. You break your skills required to solve the problem into many smaller steps. Okay, you know how to add fractions. That's a very important skill. Okay, understanding fractions is one thing, but knowing how to add it fast and quickly, that is something separate. Now in a big problem, you will use this as a step. It won't be the full problem, but that step you can do well only if your skills are built, and that's very critical. Like for example, what I did when I was trying to ask you, I drop a ball 45 meters, how much time? 45 meters, how much time? 3 seconds. Now 5t square is 45, t is equal to 3 seconds. That you should be able to do. Because the actual question won't ask you if I drop a ball. The actual question will tell you, I throw it with 8 meters per second. 45 meters height. So you'll say, okay, if I drop it, it must be 3 seconds. 8 meters per second, 3 seconds. That is concept. But you use skill to calculate the 3 seconds. Then you said that basically applies to that other problem, concept, right? So that kind of connection you make. Then you will go ahead and say, can I use that to find the range? Can I use that to find the horizontal displacement? All that is the next step. So the third step is basic applications. Basic level applications. Single concept applications. Application means 2-3 skills will come in. It won't be one skill. It will be 2-3 skills. So skill building, you take one skill, become a master at it. Application, you learn how to combine 2-3 skills to solve the problem. But when you get to IIT kind of questions, usually these are multi-concept applications. It won't just be projectile motion. It will be projectile motion and energy. It will be something like I'm throwing this ball from here, it goes and hits somebody else, and when it hits that person or hits that ball takes off, you have to use momentum conservation to solve the problem. Right? So you will need to connect 2 different concepts, but to get to this point, you need these 4. Then finally comes exam strategy. Well, you have been preparing, but you must also score well in your exam. So if you want exam strategy, how do you answer in an exam? How do you not get stressed out? How do you conserve time in the exam? Okay, how do you avoid making mistakes? How do you check your answer? Now all these, there are lots of small strategies that we will focus on. Okay, but the important part is this. Because what happens is many smart, very smart students like you, often you say, these are all easy problems, I can solve them. Let me go straight to the hard problems. So what will happen is, you will be very good at 1 or 2 hard problems, but there are skills that you are weak at. So these skills will come back to haunt you for even these basic level questions. So to be able to really consistently solve hard problems, you need skill building. And projectile motion is one of those topics where focused skill building makes a huge difference. You can in fact solve all the projectile problems mentally if you did enough skill building. So in these books and in this the exercise sheets that I've given you, the questions are all graded that way. The online course also have a whole bunch of videos. That's exactly what I'm expecting you to do. Learn the concept, which is quite straightforward, you can see. Then focus on the skill building by doing problem after problem. I have given you very graded structured problems. So if you keep solving them 4, 5, 6, 7 questions on each sub-skill, your skill becomes strong. Your skill becomes strong, you can apply it everywhere, you will never forget it. Okay, this is the approach you must use for IIT preparation. So keep that in mind. So many of you have probably been seeing this whole thing on the YouTube channel, right? So we have started this YouTube channel, Aha Guru IIT JEE NEET YouTube channel. There are a whole bunch of other Aha Guru channels which are not going to have so much information as this one. So please do join this channel. Every week I'll be posting challenge questions here. So I'll post 3 kinds of things. I'll post concepts. This is free for anybody to join, so just go ahead and join it, just subscribe to it. I'll post key concept questions. For every one of these, I'll give you also solutions. I'll then throw in a lot of challenge questions, both in mathematics and physics. Okay? And also I'm hoping that Professor D.P. Shankaran and Santanam sir, etc. will also come in and throw in a lot of interesting chemistry questions. Okay? So we will be doing concepts, questions and challenge questions particularly. These are concept level questions, skill building questions. Okay? And we will also do lots of challenge questions. So please do subscribe to this channel. Okay, so you're already at the channel, so just go ahead and click on the subscribe button. So once you subscribe, you will get a notification. Also make sure that you get all the notifications. So click on that bell icon, and then we'll make sure that every time I'm posting a question or a video, you can take a look. Always try the question before you see the video solution, because the whole point is if you do try the question, then the solution video makes a lot of sense. If you didn't try it and you just looked at the solution, then it makes less sense, okay? Because you have not tried it, you won't learn as much from it. Anyway, so I hope you enjoyed the class today. So thank you. Any comments, please put it down so I'll be able to check it out on the channel itself. Thank you.